Okay, so let's look at the homework assignment. So now that we have this thing checked out, I'm going to go ahead and launch it real quick just to see where we left off. I do this on the pixel. Is that what we did last time? All right, so here's the current version of our app. We can enter in some numbers, right? And then we would add the elements. We did a remove number thing as well. But the whole idea was, you enter in several different numbers and aren't necessarily in the right order. And then you hit sort, and sort should sort some stuff and then put it back into the scroll view should show them sorted, correct? All right, so we got kind of two different things to work on here. One is let's get a sorting algorithm going. So we'll look at some options for sorting algorithms. And then, so let's make sure our data gets sorted first. Then I want to address getting stuff taken out of the scroll view and putting it back into the scroll view in the sorted way. Okay, and we're gonna look at a couple of versions of this to kind of work us towards what might make the most sense. Like, what's the correct way of doing this, or a pretty good way of doing this versus what's a way that works. All right, something like that. So let's start off with, well, let me review real quick and see how we wrote this last time. All right, so right now I have an array called the text views. So we're supporting up to 1,000 text views up here. And whenever we add an element, we're saying if there's something in our input box, go ahead and create a brand new text view, set its text equal to whatever the value was, add it to my scroll view layout, then add this to my text views, and then also increment my number of text views, and then set the text to nothing. Similarly, well, we didn't write this yet, but when we do on remove element button pressed, we probably should bring this code, either get rid of the remove button or bring this up to date to make sure it manages your text things correctly. So if we're removing at view 0, then I probably also want to remove, well, let's ask you this. Do I actually need to remove what's at bucket, what's in my bucket of the text views, or could I just decrement number text views? Because number text views tells me out of how many out of those 1,000 text views I'm actually using, right? So I've given myself the ability to store 1,000 text views. So if I have 3 text views up there, and I decide to remove the most recent one, now I'm down to 2. I don't actually have to remove it from the array if I don't want to. I could just decrement the number of text views I have stored so that when I go through all those text views, it thinks I have one less than I used to. Make sense? Because when we put something in there, when we add an element, we're adding an element at position this.num text views. Then we're incrementing this.num text views. So here, when I remove something, I would say this.num text views minus minus. And if you really, really, really wanted to get rid of stuff, you could say this.the text views at bucket, this.num text views is equal to null. So go ahead and mark that we have one fewer text views than we had before. This visually removes it. This removes it from our count. This actually overwrites the data that used to live there with null. Make sense? So this is for our remove button, which you didn't have to have in your homework, but since we already had the remove button there, we might as well make sure it's functioning. So when we add stuff, it puts stuff in this text view. We remove stuff, it removes stuff from that text view. Okay. Now, what would be probably handy for us is right now we're storing this collection of text views. It would probably be handy for us to also store the corresponding numbers. So we could do it that way, or we could ask a text view when we get its text. So for instance, if I say, just like tv.getText. Yeah, tv.getText. So I can ask a text view what its particular text is, what the value that's currently on it is to get its number. All right, so let's do it that way first, and then we'll upgrade our solutions. All right, so when we have our sort button, this is where we're going to actually sort the stuff. Before we refill the scroll view, though, I'm going to print it out to the console. So I will just make sure we have our numbers correct. So first thing I'm going to do in here is just to make sure that we know how to run through our, I'll go ahead and get rid of this guy for right now. I'm going to go ahead and print out all of our current numbers, just proving that we have access to them. So we'll say for int I is equal to 0, I is less than this dot num text views, I++. So it's going to take I out a voyage between, for the number of text views we have. And each time through, we're going to say system.out.println. Say this dot the text views at bucket I. Now that guy is a text view. So I need to get the text from that text view. And then for right now, get it as a string. But shortly, I'm going to need to get the numeric version of that because I need to compare it to other numbers, right? Because right now it's in a format that we can't necessarily work with. All right, so this will prove to me that I'm able to grab those values. All right, and this is going to be out at the console. Let's start with this. So when I hit sort, I'll add 2 or 3 values. I hit sort. I should be able to go look at logcat and see the 2 or 3 values printed out there. All right. So we'll do a 2, a 9, and a 6. I'll go ahead and hit sort. We'll come down here to our terminal. No, it's not terminal. Android monitor. Yep, here's the 2, the 9, the 6. All right, so we're printing out those values. Now, I need to make sure I have the numeric version of those values. Right? I need to make sure I can get the numeric version of those values. Because if I come in here and I say, well, let's just go ahead and add 1 to each of those. So if I say +1 there, our hope would be to get a 3, a 10, and a 7. Right? But what are we actually going to get? What kind of animal is this? Cat, dog, string, or integer? What I have highlighted right there. It's actually a string. We wish it was an integer. Make sense? Because this is the text that's on this text field, this text view. So I got this label sitting here, and I got a number on it. But that's stored as a string. I need to get it into an int eventually. But right now, it's actually a string. So if I take that string and I try to add 1 to it, it's going to concatenate a 1. Well, it converts it to a string instead of a what is called editable or whatever the guy was there. Get text gives me a what? This gives me a char sequence. And then if I want to get the string version of that char sequence, I do .toString. So this is still a string. Well, there is. We just haven't used it yet. Yeah, we don't have it yet. Yeah, so, and it's not quite equivalent to this, but we have a way of doing it. All right, so This guy is a string. Therefore, when I say plus 1, how is it going to treat this plus sign? Is it addition or concatenation? The concatenation. So this will become 2, 1, 9, 1, 6, 1. Make sense? Let's go ahead and run this again. So we'll use our same values, 9, 6. There's our sort. 2, 1, 9, 1, 6, 1. Not quite what we wanted. We want the integer version of this. Okay. So now we got to get creative. Now the good news is that in 535, as most of you know, that you can only solve problems using things that I've introduced in class, right? So I purposely hold back certain things from you to make problems more difficult because I like torturing you. It's a hobby, right? But you did have the function in 535 that allowed us to convert a string into an integer, but it was given to you after a hard problem. You remember process expression? Remember that one? That was a fun one, wasn't it, in 535? Did you like that one? Process expression? That was a good question. Yeah. No, most people don't like that one. So what if we forgot how to convert a string into an int? So if I had the string 123, and I want this to become the number 123, I'm telling you there's a shortcut in the language to do this. And we'll use the shortcut in a few minutes. But we really need to be able to practice doing these things ourselves, right? And the fact that you asked the question, well, isn't there one of those? Well, maybe not, but why don't we write our own? Right? Good practice for us. We're getting back to the swing of programming. So if I want to write a function, here we'll write a little private function. So a private int, let's call this guy string to int. I like to use TO. String to int. This guy will take a string as a parameter. And his job is to take whatever string you pass it, we can assume it's got numbers in it, and it converts it to the integer equivalent. So when I'm looking at this string, how do I get this integer from this string? Huh? Okay, so I'm reading the indexes. Tell me more. As humans, when we look at the string 123, we instantly know that's the number 123, right? We can convert it easily. If you remember back from 535, we said one of the struggles, the hard part for programming for us, is that as human beings, we are so good at solving problems that we have problems articulating how we solve problems. And it's even worse today because what do we immediately do? The second most of you saw this question, what would your first go-to move be if I'm not sitting in front of you? Google, right? Just Google it. Well, we're problem solvers. We enjoy programming. You know, you ever just sit down in front of Netflix, you're just watching shows, and you just sit there and write some code? Or do you write code while you're crying yourself to sleep? You don't write it just for fun? Soon. Not yet, but soon? Soon. Yeah, that's what we're going for. Okay. So, when you looked at that number as a human being, you immediately could say, oh, that's number 123. All of us, right? Every one of you could do that just by glancing at it. Didn't even have to give it much thought at all. How? How'd you know that? Do you have every number that could ever be written memorized? You know, it's like if I have a whole table of fruits we put out here and I hold up an orange. You all say, that's an orange. Okay, and that's a banana. And then I hold up this fruit you've never seen before, you know, like from some island somewhere has all the spikes on it and stuff like, you know what I'm talking about? Like some of those weird fruits. You might not know what that is. You're telling me you know every single number. There's an infinite number of numbers. So it's not that you memorized 123 and we just lucked out that the example happened to be something you memorized. I could put any number in there, right? No matter what number I put in there, you would say, oh, that's the number, whatever. You know how numbers work. Specifically, you know how the base 10 number system works. This guy is in the ones place, tens place, 100s place. So this is 1 times 100 plus 2 times 10 plus 3 times 1. That's 100 plus 20 plus 3, which is 123. Right? So all we have to do is do some addition. So we're going to keep track of what place we're in. We'll always start on the ones place. We have to start at the right-hand side of our string. So this is the ones place. Multiply by 10. Now it's the tens place. Multiply it by 10. Now it's the hundreds place. So on and so forth as we move towards the beginning of the string. So parent I is equal to s dot length minus 1. That's the last legal bucket in my string. That is the string that's in the ones place. That's the character that's in the ones place. Keep going as long as I is greater than or equal to 0. Subtract 1 from I each time. So that for loop will take I on a journey from the end of our string towards the beginning of the string. Correct? Now each time through, we'll just go ahead and throw it here at the very end. We're going to say place is equal to place times 10. Because we want, this is the ones place, times 10 is the tens place, times 10 is the 100s place. We want it to keep going up as we move towards the beginning of the string. Now, each time through, though, we need to figure out what number is this. Because how do I get a particular character out of a string? I use the char_at function, right? So if I say s dot char_at I, the first time through, that's going to give me a 3. Then it's going to give me a 2. That's going to give me a 1, right? But what kind of value will it be? It looks like a 3, but is it an integer or is it a char? Well, you want it to be an integer. But what does char_at I give me? If this is s and I say char_at bucket 2, that's going to give me the char_3, that guy right there. That is not the number 3. That is the character 3. Can't do math with that. Right? Well, you actually can do math with it. It'll do Unicode math, not the math we want it to do. So now I have the question of how do I turn the char_3 into the integer 3? So another little function here. Private int char to int. This guy takes a char_c as a parameter. And for example, if it took in the int, or I'm sorry, if it took in the char_3, it should produce the number 3. That's what this function should do. We're writing this ourselves, using our own brains, using just the primitive type stuff in Java. We're not doing anything special. We need this tool, so we're going to write it. We're going to build it. How many possible characters would this guy take? In the base 10 number system, what are the possible characters that an individual digit can be? It's base 10, right? So do we have letters in there? Do we have A's and B's and C's and D's? Or is it just 0 through 9? Yeah, all the numbers that we write in base 10 are just uses 0s through 9s. So we actually only have 10 different numbers here, right? So if we just absolutely couldn't figure out some sort of shortcut, couldn't we ask the question like, if C is equal to 0, the char 0, return the int 0. Else if C is equal to 1, return 1, so on and so forth. Couldn't we do that? It's only 10 questions, not the end of the world. But there's a better way probably. But we could do this. Is there anything wrong with writing it this way? As long as it works. Most important, if you have code that works, even if it's inefficient, that's way better than code that's efficient that does not work. Okay? You're not trying to impress anybody when you write your code. You're trying to get accurate code written. Through years of experience, you'll get your average solutions will become more elegant. Okay? Once you're writing it, but nobody cares. 99% of the time, the most elegant solution and the crappiest correct solution are the same. They run in the same amount of time, relatively speaking. Right? So it doesn't matter. You're talking about something that maybe comes into play 1% of the time max, where every now and then a really elegant solution is just needed for a very specific problem. Okay, and through years of experience, you'll become that person that can do that, right? But right now, always fall back onto code that makes sense to you. Don't try to overthink the problem. Don't try to come up with some sort of magic trick or, even worse, invent a function. Okay? And for your own good, don't just dive into Google and look for answers that you don't understand. So fine, it works, but you need to know why it works because you're here to learn, right? So if this is the solution you come up with and you say, look, you could give me the char 0, I'll give you the int 0. You give me the char 1, I'll give you the int 1. Fine. It's not a big deal. Now, if you wanted to use a shortcut, we could take advantage of some of our, kind of beginner string functions that are helpful to us here. So for instance, I could say something like return that. Now at a glance, you might say, well, what the heck is that? This is a string, right? That guy? How do you know it's a string? Got the double quotes around it. Must be a string. All right. I just happen to have filled up this string with the characters 0 through 9 in a very specific order, right? I just happen to do that. Now, strings are indexed from bucket 0 to bucket length -1. So this 0 lives at bucket 0. This 1 lives at bucket 1. This 2 lives at bucket 2. This 7 or this 8 lives at bucket 8, so on and so forth. What does index of do? Index of returns the position within the calling string. This is the calling string. Returns the position within the calling string where the character we are looking for is first found. Or, what's the other thing index of does? What if index of does not find a value? Let's say I was looking for a z inside here. What would index of return? -1. Okay, so in many cases, that fact that index of returns a -1 when it does not find something is our most powerful tool associated with index of, because it effectively allows us to determine if something is not part of a set. Make sense? But we're actually not using it that way this time. This time we know that the character we're passing this guy is going to be a 0 through a 9 as a char. I just need to get the int version of that guy. So I'm going to say, look, I know that this dude will be in here. Even though index of could possibly return a -1, because I know the data that I'm passing this, I know it won't. Make sense? Therefore, I'm going to say, look, if the char I'm searching for was the char 0, go ahead and give me the integer 0, because that's where you found it, at position 0. That makes sense? So this guy will return the character version, or the int version of a char. This guy, we're hoping, will return the string, or the int version of a string. So because this gave us the a char, we need to convert that char to an int and multiply it by place. And we need to have a sum. So sum will start off at 0. You know, like 123 was 100 plus 20 plus 3. So we have to have a sum we're building up, right? So what's sum going to equal? Each time through, sum will be equal to whatever sum currently is equal to plus. We need the integer version of the current char. So that is this dot char to int. So the function we just wrote, s dot char at I. Okay, so that guy right there will boil down to the integer equivalent of the char that we're currently looking at. Make sense? And I want to multiply that by my current place, my ones place, my tens place, my 100s place. And I'll add that onto my sum. And then I'll increment place. Well, not increment, multiply it by 10. When I'm done walking my string backwards, sum should have my answer as an int, so I'll return sum. Make sense? Yeah, because this is the ones place, tens place, 100s place. The for loop starts at the end of the string and walks towards the beginning of the string. So that's why we multiply it by 10 each time, because it's representing a new place. This is 3 times 1. This is 2 times 10. This is 1 times 100. Make sense? So now, if we take this string and we pass that string to our string to int, this dot string to int, the same string, and we add 1 to it, now we'll see it's math, right? It won't concatenate on a 1, it'll add a 1 to it. So we'll do a 2, a 9, and a 6 again, and we should get a 3, a 10, and a 7. A 2, a 9, and a 6. Click sort. 3, a 10, and a 7. Make sense? All right, so now let's review what we just did up here. Now this is where, I won't say this is where you should be. You should be a little bit better than this, but based on looking at the quizzes, well, I'm going to adjust where I think all of you right now should be feeling. When you look at this code makes sense to you, right? And nothing about any part of this code looks difficult. So something I'll say pretty often is this idea that all hard programs are made up of a bunch of easy parts. If you looked at the source code for Microsoft Windows, which we would presume is a pretty big program, right? You think you're going to find integers and for loops and strings and stuff like that? You're going to find the same stuff, same trivial components that we're used to working with. You're just going to find it on a much bigger scale. So nothing about what I have highlighted there is difficult, right? Now, so most of you, well, actually all of you, when looking at this should understand what this code does now. Okay, you should be able to sit down, walk through it line by line, and understand it. Now, so now it comes down to what's the real problem, and this is really this evidence that all programming languages are the same. Because what I've had in the past is some students who will say like, oh well, you know, my background's in C and not this. Okay, fine, write it in C. Language doesn't matter. The thing that most of you are going to struggle with right now is not reading this when you see it. It's that convincing yourself that this is the way you should solve the problem, or this is the way you could solve the problem. Because the modern thinker, the modern student, and this isn't just the modern student, we just have more resources available to us today, right? So we have easier outs with Google and things like that. We don't like relying on our minds to solve problems. We've kind of thrown critical thinking out the window. Where we want to dive in and let Google do the work for us. And, a lot of times Google is good for doing the work. I use Google all the time. But I've already solved a lot of these problems. So a lot of times I'm letting Google do something for me for convenience, right? But for you, you're actually doing yourself a disservice right now from an education perspective if you rely on Google too much to give you answers to problems that you could have the pleasure of solving on your own. This should be infuriatingly fun, solving problems like this. What's really nice about this kind of problem is just the simplicity of the question we're asking and how our inability of solving it, right? Any one of us could have looked at the string 123 and says that is the int 123. Trivially, every one of us, right? But when we were forced to think about, well, how would we solve that if we had to on our own? We immediately hit a roadblock because numbers are so trivial to us that we don't think about them. We don't think about how numbers work. It's almost like the perfect evidence of how we've become so good at solving problems, we've forgotten how to articulate how we solve them. We don't think about numbers at all. That's something we learned when we were, we were still throwing up on ourselves and stuff. I mean, it was so long ago. So this is like the perfect lesson for us to realize just how much stuff we've forgotten how to explain. Does that make sense? So I really, really, really encourage you when you're trying to solve a problem in these programming assignments, if you just don't immediately know the tool that you might already have been introduced to that will help you solve the problem, like, oh, is it char-at? Is it a capital A? Something like that. You know about char-at, right? So at that point, you can go and look it up and just look at the reference to find out whether it was a capital A or a lowercase a. But if you're like, well, was there a tool for that? If you're questioning it, assume the answer is no. Make your own. Write your own little tool for it. Because it'll give you good practice. Because these little exercises, things like this, these are the things you do to become a good programmer. Because now you're not reliant on the extra bells and whistles the programming language gives you. You now have a skill set as a programmer where as long as you have the bare minimum stuff, as the programming language can just do the basic programming language stuff, memory, asking questions, and repetition. If you can do those three things, yeah, you can pretty much solve most of these problems, right? If you're relying on yourself and your own brain. And then over time, you'll kind of collect a larger tool set of stuff that will make you solve problems more easily. So most of you, your biggest hurdle here is not reading this code. And it's probably not even writing this code. It would probably be more difficult for you to write it than it is for you to read it, as kind of intermediate programmers. But your biggest hurdle is deciding that this is the problem you actually need to solve. I need to walk this string from the end towards the beginning and build up my base 10 number. So it has nothing to do with programming. It has everything to do with that we forgot what numbers mean. Make sense? So it's the more times you can give yourself the opportunity to practice slowing your mind down and really thinking about how to solve a particular problem, the better off you'll be. Because then you'll become more reliant on your own critical thinking, and you'll be surprised how quickly you recognize that you're actually way smarter than you look. Okay? Think about the number of things we don't even think about. We just do passively. I mean, just staring at this number, just immediately knowing it was 123, you didn't use your brain. It didn't feel like you did anything. It was just a fact, right? We're all geniuses. We know tons and tons and tons of stuff. We just forgot how to access it. So give yourself lots of opportunities to practice writing these things. And all of a sudden you'll start unlocking, almost like greasing the joints, right? You'll start remembering, oh my God, all this stuff that I've forgotten how I knew it. And you'll be able to start solving larger problems. Okay? So don't pass up opportunities to solve stuff like this. Well, that's not a fair statement. Every single time any program takes an input? No, I mean, when we're talking about Android, since our inputs are coming from like text boxes and stuff like that, it'll always come in as a string. It's just kind of the nature of the tool we're dealing with. In Java, we can use the scanner, for instance, to read something in from the command line and actually get it as an int. So it's not. So your statement about all programs, it comes in a string, is not accurate. But with Android, just because of the tools we're using to grab data, it's usually a string. But if we had a drop-down box, something we scrolled through and hit a number, there's no reason why that couldn't be an int. Yeah. So it really is just how it was delivered to us, and so that's a skill in and of itself. Is kind of looking at, here's my data, and I'm holding it in front of you, like, what is this? What kind of animal is this? Okay. And this is another thing we saw several times. I mean, actually, we've seen several examples today where one person will say, this is what it is, and another person will say, this is what I hope it was. Well, those are the answers they get, right? Like, oh, well, it is a string. Wish it was an int. Those two things, right? As early programmers, we tend to allow our hopes and dreams to take over what the thing actually is, right? It's like, oh, I really want that to be an int, so we're just going to assume it is and watch my program crash and burn is what ends up happening, right? So really take some time and get good at looking at something like this and just asking the question, what is that? What will that be? Because that's a whole lot of crap that ultimately will boil down to just one value. Now, we got a pretty good clue right here at the end where it says toString. You should strongly suspect it's a string at that point. Okay? Otherwise, it's just a really, really misleading method name is what it is. But we know that this is this object. We know that we created this array called the text views. Well, what is the text views? The text views is an array of text view objects. Okay, well, what's a text view object? That was that Android thingy we learned last week that we can type stuff into it, right? So it's an Android thing, but it holds stuff. All right. So that guy at bucket I will be a specific text view, right? So instead of a collection of text views, now I'm grabbing one of those text views. Now I have a specific text view. And what am I doing with that specific text view? I'm getting its text. Well, text sounds pretty stringy to me, right? Now, we kind of talked last time that in Android, sometimes the text comes in like a character sequence, like weird formats. So we have this toString method that makes sure that we get it in the string format because we like strings as Java programmers. So at the end of the day, we kind of piece apart that and say, oh, that's a string. And then we say, I really want it to be an int. Now we can say it's a string that I know looks like an int, because we do know that. We know that this guy is built up of digits, correct? So this is a string that looks like an int, therefore, I need to have a way of converting it to an int. So in this case, we wrote our own, the string to int function up here, which required us to write this char to int function to accomplish this. Now we could have also done this like that. There exists a class in Java called integer that has a function called parseInt. And it takes a string as a parameter and parses the integer version of that string. does exactly what our function did, string to int. All right, so now as another review, and this is important stuff. This is stuff that we all should know in this class already. What kind of function is this? Is this a class method or an instance method? And how do you know? Remember that stuff from 535? Remember me saying how important that stuff was? We used to repeat it over and over and over again. And now all of you forgot it? It's an instance? Is it a guess or do you know? That's what it should be. Why? That doesn't make sense. Tell me why. You want me to give you a hint? I'll give you a hint. You said it's an instance method, right? Okay, so here's your hint. Tell us why you're wrong. So it must be a class method. How do you know this guy's a class method? Now what we're looking at here, this is us calling the method, right? We have two distinct kind of modes that we can be in. We could be calling a method or we can be writing a method. So up here, we wrote a method. This method is an untapped resource until we actually call it. So when we write a method, how do we distinguish that method from being a class method or an instance method? When we're defining it or when we're writing it. Not private. Starts with an S, one very important word that's not on this function. Static. Static. So the keyword static, if it's there, it means it's a class method. If it's not there, it means it's an instance method. This guy was an instance method. That's why we called it by saying this dot string to int. We use an instance of the class in which the method was defined to call it. Here, parse int. Did I create a variable here? Did I create a variable anywhere called integer? No, not us, right? So integer must be what? Somebody else's thing. We can say that shorthand, right? It's somebody else's creation, not ours. Now, the fact that it starts with a capital letter kind of probably hints us into what? What kind of animal is that guy right there? Class name. Yeah, it's a class name. So class names by naming convention. This is not a rule, but by naming convention, typically start with capital letters. And the fact that we know we did not define this variable. Therefore, as far as we're concerned, nowhere in our scope do we have a variable called integer. And trust me, if you tried to create one, it would scream at you. Therefore, if I'm calling a function with this guy, he must be a class name, and this must be a class function. So if I were to go into the integer class, and I were to look for the parseInt function, would I find static in front of it, or would I not find static in front of it? What do you think?
You won't find it in front of the class name.
Yeah, so in front of parseInt, I will see static. I won't. If I go into the integer class, so this is me using it. If I go into if I have the documentation for integer, will I see the word static in front of parseInt? I'm calling it using the class name. So that means this guy is a class method. How do I define class methods? With static. So you think I will see static in front of it? Okay, do you want to disagree with him? Are you afraid to disagree with him, or you just don't? Are you confident? Confident that we will see static there. All right. We're going to go look it up. Are you willing to bet your grades on this? And the good news is you won't have to come to class anymore. All right. So Here's integer. Here's the integer class. We'll scroll down to parse int. Right here, and we find static in front. And because we find static in front, we know how to call this function. We call this function, we say, oh, it has static. That means it's a class method. How do we call class methods? We call them using the name of the class in which the method was defined. What class was this method defined in? It was defined inside of a class called integer. So I would call it by saying integer.parseInt, just like we did right here. Does that make sense? This is not just Java knowledge. This is something that transcends all object-oriented languages. Okay? Some languages have different ways of representing whether something is a class method or instance method. C# uses the same format as Java, static versus non-static. C++, also the same thing. How did they represent class methods in C? Trick question. Why is it a trick question? What's a class? A class is how we represent objects in object-oriented languages. C is a procedural language, right? Our first object-oriented languages in the C lineage was C++. So we didn't have a delineation between instance and class methods in C. We didn't have classes. Make sense? All right, but all of our modern languages are object-oriented languages. We have a delineation. Everything that came directly from C, or from, let's just say C++. C++ used the static, non-static thing. Java uses static, non-static. C# uses static, non-static. Swift uses static, non-static, which is over on the Apple side of things now. But interestingly, Objective-C, the previous language to, have any of you ever worked in Objective-C? Objective-C, instead of static versus non-static, they would put, so for this one, to make it an instance method, they would put a minus sign before it. Minus means instance, plus means class. It's actually kind of an interesting, maybe even in some ways better when you think about it, because it's a little bit difficult to, because we're saying, well, is it a class method or is it an instance method in here? But really what you're looking for is whether or not static is there. Where in Objective-C, you always have something out front, and that something tells you what it is. If it's a plus, it's a class method. If it's a minus, it's an instance method. You don't have this thing of something or nothing. Make sense? So in some ways, you might say it's better, but the point is that even though they use a different syntax for it, it's still the same concept. Class methods versus instance methods. Class fields versus instance fields. So what's the difference between class methods and instance methods? It's a little bit of a loaded question. Maybe the better way of that, it's not so much as a difference between the functions themselves. It's when would you make something a class method versus when would you make something an instance method? Like when is it correct to use each one? So if I have this tool here, so we go to Costco, okay? We buy this box, almost looks like a toaster, okay? This box. And I could take a string and I can throw it at the box, and on the other side, what pops out is the integer version of that string. Now I could just sit here with just a pile of strings, right? Just keep throwing it in there, get the end. Keep throwing it in there, get the end. Keep throwing it in there and get the end. This is like a factory, right? I only need one of these guys. And I'm gonna serve it strings. Just keep throwing them in there, right? It would make sense for this guy, if we say this guy's a method, it would make sense for him to be a class method. We only need it to exist one time because we're going to provide it with its inputs, the things we want it to operate on. All right? When would it make sense for it to exist multiple times? If we, for instance, if we were building that ability into the string class, let's say we decided that all strings knew how to convert themselves to ints. Which would be That's not an unreasonable thing. The string class in Java does not know how to do that, which is why we have the integer class. But you could make an argument that that would be an interesting thing for strings to be able to do to themselves, right? Had they done that, then it probably would have been an instance method, because we would have said, okay, well, here's a string. I want you to convert yourself to an int. So I would not provide it with input because he already knows about himself. And he would throw out the int that's equivalent to him. Then I'd pick up the next one. I want you to convert yourself to an int. I wouldn't have to give it any input because he already knows about himself. Gets the int out of there. Does that kind of make sense? So it's not that one method type is better or worse than the other. It's kind of like what makes the most sense based on how you're going to use it. And there isn't a right or wrong answer. There's just consequences to it. If I'm going to implement a method as a class method, chances are I'm going to have to give it some input because it doesn't have an instance. It doesn't have information to draw upon to let it know about stuff that it might otherwise know about. Like a string already knows about the characters that make it up. But this integer class doesn't know about any individual integer. It's just a toaster just sitting here. Okay, toasters don't just spit out toast. You need to put bread in for it to make some toast. Does that make some sense? Yeah, so one's not lesser or greater than the other. They just have different purposes. Typically, class methods take inputs or take more inputs, where instance methods would take less inputs. Because at the very least, an instance method knows about the fields associated with that instance. Okay. So, in any case, we can use whatever version of this we want. Here's the integer.parseInt. So we have this tool built into the integer class. The makers of Java, Sun Microsystems, now Oracle, they decided, you know what, instead of allowing strings to convert themselves to integers directly, why don't we go ahead and create this factory class called integer that puts stuff into it for working with ints, working with integers. And that's kind of a useful thing in Java because the only other way we have for storing ints in Java is through the int primitive type. And primitive types can only hold a value. They can't do anything else. I could say int a is 5. That guy is really, really, really good at holding the number 5. But he can't do anything else. He doesn't have any methods. He doesn't have anything. So this integer class is pretty important from the perspective of if you want to do stuff with ints, it might be helpful. Make some sense? All right. But again, you didn't have to know that guy existed in order to solve the problem. Okay. I knew he existed. I've been doing this for a few minutes. Most of you probably suspected it existed. Something that makes sense, right? But the reason why I really, really want to encourage you to force yourself to do stuff like this, at least for now, is because what ends up happening is you get stuck for 2 or 3 or 4 hours when you're working on your homework because you're looking for this magical silver bullet function that solves your homework instead of relying on your brain to solve stuff. It's like, I need to find the magical method that will remove a whole bunch of text fields from a scroll view, sort them, and then put them back in that scroll view. Google. And that's what we do. Don't rely on somebody else to do your homework. Whether I give you an A or whether I give you an F doesn't mean anything to me. It's just a letter grade. You want to know this stuff because you're going to go into industry and need to use it. Okay? You don't want to be that idiot with a nice GPA. You want to be the smart person with a nice GPA. I'd love to give all you VAs. The letter grade is meaningless if you don't have the knowledge. You'll just get fired from your first job. You'll say, oh, I spent all this money on this degree, and now I can't hold a job because I'm an idiot. Man, I got good grades. All right. Yeah, sometimes the truth hurts. It's a thing. All right. So I really encourage you to do stuff like this. All right. So in any case, now we're convinced that we have numbers, right? All right. So now let's go ahead. And since we're convinced we have numbers, now we want to sort these numbers. All right, so what I'm going to do is I'm going to go ahead, I'm going to load these numbers into a, well, we have to decide how we're going to sort them. So we have several different possible algorithms for sorting. But what I'm going to do, just to keep things relatively simple and kind of really, leverage this idea of write your own stuff, that we've been talking about, we're just going to do a kind of a brute force sort. So if I put 5 numbers in front of you, I say, which number is the smallest? What are you going to do? Well, you're going to look at the 5 numbers and say, that one. That's the smallest, right? Now you got to stop for a second and say, well, how did I do that? Well, maybe you took the first number, you held it up, and you compared it to each of the other 4. Like, is this one the smallest? Yep. Oh, nope, new winner. Put that one down. Grab this one. Smallest. Keep going, keep going. Ah, I checked them all. This is the smallest. Smallest number, right? Move on. So what we probably want to do is we want to go ahead and get these, we want to put the text views back into our array, or back into our scroll view in a certain order, correct? The first thing we want to put in there is the smallest value. The next thing we want to put in there is the next smallest value, and the next smallest value, so on and so forth. Say that again. Starting within the array. Well, we can decide. We can decide. Is it actually important for this homework assignment that the array is sorted, or is it important that the stuff is put into the scroll view in order? You know what I'm saying? Because ultimately we believe it's sorted if we visually see it sorted. I don't need to necessarily rearrange my array. I just need to empty out the scroll view and then go through my array and say smallest, next smallest, next smallest, so on and so forth. But in order to do that, I'm going to kind of need to mark off the guys that have already been used, right? Because like if I have 5 numbers in front of me and I find the smallest one, I take that guy out of circulation, right? He's no longer in there, and we kind of have a weakness with that right now, because I have this like array that has 1,000 buckets in it, and I have a limited number of things in there. But so why don't we write a function that says find the smallest? We're going to find the smallest value in there. So we're going to write a private text view, because this guy's going to return the smallest text view. Okay? So private text view, find smallest. And we don't need to provide him any input right now, because this guy's inside of this class, so he knows about the text views. He knows about my collection of text views. All right? So we're going to have a text view here called winner. That guy will start off as null. I don't have any winners yet. Okay? Then we'll go ahead and we'll say, well, I need to go through all of my text views that I have. So I'm going to say for int I is equal to 0, I is less than this dot num text views, I plus plus. So I'm going to go through all my text views. And each time through, I'm going to ask, is the current text view I'm looking at, does it represent a number that is smaller than my current winner? Go ahead. We haven't converted to anything at this point. Oh yeah, I mean, don't look at anything beyond what we see right here. We can think about how we intend to use this tool. But right now, I'm writing a self-contained method that's going to go through and out of my collection of text views called the text views, I'm going to return the one text view that represents the number that is the smallest. I have some other tools that will help that we've written today that will help me figure that out. But ultimately what I'm doing is I'm returning the text view that has the smallest number on it. They haven't been pre-converted or anything. These guys are text views. Normal plain Jane text views, we have to get the text from them. We have to say toString. If I want the numeric version of it, I have to call my function or I have to use integer.parseInt. I still have to do all that stuff. But now we have those tools that we've written, so we can just pick up the screwdriver and use it. Make sense? All right, so I'm going to go through all my text views. We'll ask the question if winner is equal to null. So if I do not currently have a winner, actually we could do this a couple different ways. We say if winner is equal to null or integer.parseInt of some number. What number? This dot the text views at bucket I dot get text dot toString. So if parseInt of that guy is less than, let me kick this down a line just so you can see it a little better, is less than integer dot parseInt of winner dot get text dot toString. I don't know which of those looks better. Spread this over. So if either winner is null or the guy I'm currently looking at is less than my current value of winner. So the integer version of the current text view is less than my current winner, the integer version of that. If either of those is true, then I'll go ahead and say winner is equal to this dot the text views at bucket I. I'll replace my winner with the new guy. So if winner is equal to null, this is the first guy I found, I won't go over to this or. It'll just do this because or is only one side needs to be true, so it won't even check this other half if this part is true. Otherwise, I'll only replace winner if the other guy is bigger. Make sense? Okay. So what will I do here? After this whole for loop is done, whatever's currently in winner should be my text view that has the smallest winner in it. So I'll go ahead and return winner. Okay, so now let's go down to this on sort button thing. And I'll go ahead and print out the text from find smallest. This should find the smallest of my text views. I won't find all the smallest, just the one smallest right now. So I'll go ahead and print out this dot find smallest, which will be a text view. So got that text get text dot toString. So find smallest returns a text view. I'll get the text from that text view and then convert it to a string. And I'll print that out. So now when I hit the sort button, it's going to go ahead and give me the smallest of all my text views that I currently have up there. So if I say like 9, 3, 6, the smallest of those should be the 3. So I'll go ahead and say sort. And there's my 3. Yeah, I have it inside of the loop down here. That's why it did it 3 times. It found the smallest 3 times because I have it inside of num text views. Make sense? So now we have the ability to find the smallest. Well, great. How do I find the next smallest? Yeah, I found the smallest. How do I find the next smallest? I look back at this guy, the next guy should be a 6. I already found the 3, but how do I find the 6? I have to know that I already found the 3. So I have this single array with text views in it. I said, okay, you're the smallest. I got that here. Like, okay, but now I need to find the next smallest. No, it's not the 3 because I already used him. Now I got to look at these other 2. Kind of understand the problem we're trying to solve here? Okay. So how are we gonna remember the smallest value we already found? What if we made a copy of our array? So we made an array that had just the correct number of buckets in it for the number of elements we have. We copy everything into it, and after we find a winner, we overwrite that bucket with a null. Kind of mark it as no longer valid. Make sense? So we kind of show you what I'm talking about here. So inside of sort button here, I'm going to go ahead. We're going to create a text view array called temp. And this guy is going to be equal to a new text view array. And its size is going to be this.num text views. So it's going to be able to hold the number of text views that we currently have in our the text views. So it's the correct size. So I'm going to go ahead and I'm going to fill it up with all of my current text views. So it'll be in 2 places. They're still pointing to the same text views. I'll just have a pointer here and a pointer here that both point to the same one text view. So I'll go ahead and say for int I is equal to 0, I is less than temp.length, I plus plus, we'll say temp at bucket I is equal to this dot the text views at bucket I. So this will just fill up temp with everything that's currently in the text views. We're not removing it from the text views, just putting it inside of temp. Because temp is going to kind of be where I keep track of my winners. Make sense? Okay. Then what we're going to do, we know, and keep in mind that this for loop and this for loop, even though they say something different, will go through the exact same number of times. Because temp here was built in terms of num text views. So temp.length is equal to num text views. Makes sense how this loop and this loop are literally identical in terms of what they do, even though they say different things on them, because their numbers are based on the same thing. So what I want to do here then is when I call find smallest, I want to pass it my temp array. I want it to find the smallest out of my temp array. That way, when it gets its answer, it can mark it off. Make sense? You throw a null there. There's solving probably like a little puzzle. You follow what I want to do here? Okay, so I have my list of 3 things here. I found my 3. Now, before I return this 3 as the smallest, I'm going to mark that guy off. Okay, so I don't want to find that again. Okay, I'm going to mark him off. Now, I'm marking it off inside of temp, not inside of the text views. So I haven't broken my original list of text views. This temp is just for the sorting stuff. I'm not sorting either of them. I'm just looking for my smallest inside of temp. But when I find a smallest, I then remove that guy from circulation inside of temp. So find smallest is going to go ahead and take in a text view array. We can call it temp if we want, but we can call it whatever we want. I'll just name it temp so we know that those 2 are kind of connected. That's how we intend to use it. I'm not just going to keep track of my winner. I'm also going to keep track of winner pause. Because I need to know where my winner was found so that before I return the answer, I can mark it as null. I can remove it from circulation. So I'll go ahead and even though we've already just said that this is the same, I'm going to say temp.length here. Because at that point, it's something called coupling, where we're relying on our knowledge of how we intend to use this tool. We're going to pass in some text view array here, and we want to go through every element of that text view array, even though we know exactly which text view array we're going to pass to this. So we could make some assumptions, but it wouldn't be very good programming practice. So I'm going to go through all my elements of temp. Each time through, we'll ask the question if winner is equal to null or the current guy, and this is not the text views anymore, now it's temp. And it's not this dot, it's just a local variable temp. So if the integer version of my current value of temp is less than my integer version of my current winner, then go ahead and declare a new winner, and then also declare a new winner pause to be bucket I. That's where I found that winner. Okay, but now we'll only do this if winner is equal to null or the current value I'm looking at is less than the current winner value. But there's one important thing we need to do here though. We need to ask the question beforehand. If temp at bucket I is equal to null, continue. What does continue do? What does that keyword do?
Stop the execution, rest of the steps, and it goes for the loop again.
Okay, so we have two keywords that work inside, well, really three, but two loop-based words. One is called break, one is called continue. Break ends the loop and breaks us out of it immediately. Continue stops the current iteration through the loop and moves on to the next iteration through the loop. This says that if I've already marked the current guy off as being used, don't check them. So if I'm currently looking at a temp at bucket I as being null, that means it was previously found as the smallest, and I've already marked him off. I've set him equal to null because I've used that value. I don't want to try to get the integer value of null. That would crash my program. If I try to squeeze the integer equivalent of nothing, break the juicer. Okay? So just do a little error check here. We're just saying, look, if the bucket inside of temp I'm already looking at was previously a winner, it's going to be marked as null. I just want to move on. Go to the next bucket and keep looking from there. Otherwise, if I'm still kicking here, I'll go ahead and do my same check, whether it's a winner or do I have a new winner. Each time through, not only will I keep track of my winner, but I'll also keep track of the position of my winner. So when all is said and done down here, I go to return winner. Before I return winner, I want to say temp at bucket winner pause is equal to null. Mark it off. I've used that position as a previous winner. Then I'll go ahead and return winner. So now down here, after I've copied the values into temp, then I want to go through temp number of times, or this .num text number of times are the same. Each time through, I want to call find smallest on temp. So if I use my same example of 3 numbers, this guy will go 3 times through, but each time through, I'm passing it the same temp array, but that array is getting modified. Things are getting marked off as we go through there. Make sense? So we'll do our 9, 3, 6. Now when I sort it, it should say 3, 6, 9 printed out to the console. This was the first smallest it found. Here was the next smallest it found after it removed 3 from circulation. Here was the next smallest it found after it removed the 3 and the 6 from circulation. Make sense? Okay, so now I'm getting them in the right order. Now, the last thing I need to do is I need to remove everything from my, what do I call it, text view or something like that. SV layout. So I need to remove everything from SV layout, then add the elements back in to SV layout. So rather than print them, let's go ahead and remove everything first. This dot SV layout dot remove all views. That'll completely empty it. Or we looked last time, you can remove a view at a certain index. You can just keep taking them out. So pick your poison. Then we'll say this dot SV layout dot add view. Let's see, we're adding, this should be fine. What view are we adding? The text view that gets returned by find smallest each time. I believe the default is it adds to the end. So there's our 9, there's our 3, there's our 6. We'll hit sort, there's our 3, our 6, and a 9. So we removed them all, then we called find smallest the correct number of times and added the winner back to the thing each time. Make sense? All right. Questions, comments, concerns. That was the whole homework assignment, right? So not too bad. It's all home cooked. Okay. It didn't go fast food or anything. We just got everything. We wrote it all ourselves. All sorts of good stuff. All right, so I'm going to go ahead and I will commit my changes. We'll call this homework 1 solution. Do commit and push. I don't want to review the whatever. There's my push. Push was successful. Come back in here. And it should have a bunch more crap in here now. Yep, here's my new stuff. So that's on the GitHub that you guys had the link to from on Slack. All right, so let's take another 10 minutes or so. So we'll come back at, let's go 7:50. And then we'll start talking about linked lists.